Hey guys, what's up? Eddie Yahoo here with KissAnalog.com. Alright, today we got something exciting to talk about, I think. JohnAudioTech and I are going to collaborate on a design, and he's done the audio amplifier design and I've done the assimilation schematic, and I'll put the links down below for his video and my video and his latest video where he talks about us collaborating. So yeah, oh, by the way, Buck Cherry. So I just noticed you couldn't see the name of the group. So all right, well, anyway, what we're going to do is I'm going to design the power supply and we'll collaborate on this. We'll go back and forth and we'll work out the specs and so on. But I think right now he was talking about in his video about a 500 VA, something equivalent to about a 500 VA, which, guys, that's a 500 VA. I gotta start lifting weights again, or lifting transformers maybe, but yeah, that's 500 VA. That's a monster. It's probably 15 pounds, I'm guessing. Feels heavier. Anyway, this is 160 VA. So, you know, kind of see the size difference, right? This one's probably, I'm gonna have to figure this one out. I've got a bunch of these. I think these are like 250, 300 VA, something like that. Anyway, we can design one that way, and I think we will. I think we'll do what we call a linear, which is really a low frequency switching power supply. That's why I call them. This is what they are. Diodes turn on and off, switching on and off. And they send pulses of current to charge up capacitor like this. Rectifiers, big old capacitor bank. So, transformer, then one of these bad boys. So, that's one way to do it. And then if you actually regulate it, which no one does because it's expensive and adds weight and costs and all that kind of stuff. But then they'll sell you power cords. Anyway, I did a rant on this, but yeah, so I think we might actually do a linear power supply and see how that works. But I'm a power supply engineer and I do switchers. I do real linears with real linear regulators. But anyway, I'll put the link below for my rant where I talk about this, linear regulators and so on, switchers. Gosh, gotta make sure I don't tip over my beverage here. It's been a long day, so I needed a beverage. Yikes. Put it on top of one of my big old bulk capacitors. Can you see that? Alright, hopefully you can see my board. What I'm doing is I'm just kind of showing you schematics of what we call linear, which is a low frequency switcher. See, low frequency switcher says so. These diodes turn on and off. They commutate, right? As the voltage gets high enough, then they charge a capacitor. Then they turn off. So they pulse. And it's low frequency. Here in the US, we have 60 hertz, so it's 120 hertz pulsating. Now, they end up with big pulsating DC current, and we use big old capacitors to try to regulate the voltage. It doesn't regulate, it just tries to stiffen it up. So it's nice and stiff and doesn't have a lot of, ripple. So that's normally the way it's done. Cheap and easy. Have an input capacitor too for some filtering and so on. But yeah, there you go. Big old transformer. Showed you that. Big old capacitors like these guys over here. And there you go. And a bridge rectifier that has to handle those big high pulsating currents. The bigger the capacitor, the higher the currents are going to pulse. So, the power supply I want to design here on this channel as part of this collaboration will be I think it'll be my first audio amplifier power supply design on YouTube channel. And what we'll do is we'll start off with power factor correction. Now, it used to be referred to as active power factor correction because when we came up with a control chip that could do this with a small high frequency switcher, they referred to that as active power factor correction. But you know, nowadays a lot of times it's just referred to as power factor correction. And the reason is a significant difference because you could add a passive power factor correction to this circuit. You could do it passively. Doesn't work as well as active. So anyway, this has become so predominant over the last, say decade, that this is such a common circuit, and it's just a boost regulator. It's a little bit more than just a basic boost regulator because you're dealing with pulsating DC. So the part of the circuit I did not show, sorry about that, is this takes off from here. So, whoops. Oops. I kind of scribbled in the part of the circuit I forgot to draw. Anyway, sorry about that. So this rectifier I put right here, and there's a little capacitor like this one right here. Then there's another little capacitor like this one right here. So these are two small capacitors and our bridge rectifier. So we make pulsate DC on this little capacitor. Because it's a little capacitor, it still is a pulsating DC. We haven't smoothed it off or anything like that. Now, sure, if you have no load on here at all, I guess that little capacitor would charge up to some DC voltage. But it's very small, like say 1 microfarad or smaller. So it's going to be a pulsating DC with any kind of load at all. Then this guy is going to convert that to pulsating square wave right here. Maybe around 100 kilohertz with this controller, okay? And now that we got a faster frequency switching through here, now we can go through this, this diode and this capacitor, and we can charge this capacitor up instead of this one. So this guy charges this capacitor, and it's going at 100 kilohertz. So this guy is going to be, I put medium, it's going to be medium to small compared to this. And I put medium for the inductor. It's going to be a donut. 500, for something comparable to 500 VA, it's going to be, a small donut. In comparison to this, it's probably small. I just didn't want you to think it's going to be like, real teeny. But yeah, this can be relatively small, especially compared to this. But, for switching power supplies, it's medium size. Anyway, so, alright, so this guy is our boost converter. It's basically just a boost, right? We turn this guy on, charge up the inductor, turn it off, and it goes through the diode, charges up the cap. And that's how it works. So, it's a boost converter. It's a little specialized boost converter because the input over here is a pulsating DC. It's not a DC like you normally have on a boost converter. So it's a little bit different in that way. The advantage of doing this is if you look at the sine wave with the current probe on this one, and if you look over here, you're going to see these big old pulses of current. On this one, you're going to see something that looks sinusoidal because all these little on and off cycles are kind of going to blend together, and they're going to look kind of like a dirty sine wave over here. But it's high frequency dirty, so it's pretty easy to clean up with some filtering. So power factor on this one is almost unity. It's not unity, but it's almost. It's like, say, 99, 98%. Where over here, maybe it's like, say, 60 or 70%. So if you have a 500 VA, that means you can only use maybe, what is that, like 300 watts out of it or something like that? Where this guy, not, if it's 500 VA, you're going to be able to use like 470 watts or something like that. So you got a lot more power handling over here. You don't lose it in power factor. Alright, then over here, after you make this, it's boost, like I said, it's boost. So you're going to boost it to some high voltage, high DC voltage, 390 volts. The advantage of having a high voltage DC, we're going to talk about why you need that, but the advantage of that is that when you switch over here, now you're going to have a transistor kind of like this one on the bottom of this transformer pulling current through it. if you're doing, let's say 390 watts over here, it's only 1 amp on this side. You know, 1 amp RMS, right? So current's low when voltage is high. So that's kind of nice. So your copper and all that stuff doesn't have to be real big and heavy. Your ripple on this guy is 100 kilohertz, so it's going to be kind of small. Now this guy's going to be switching probably faster even. I don't know, let's say we're going to switch at 200 kilohertz. So this guy's going to be pulling stuff off of this guy in 200 kilohertz chunks. So this guy doesn't have to be that big. Really, one of the reasons why we might be more medium size on this is if we have brownouts, things like that, or just dropouts for a couple of cycles. If this guy's big enough, you don't even notice that kind of stuff. All that stuff's gone too. So over here, our power is very immune to what's going on over here. This guy's going to regulate this voltage right here. So what's going on here, you know, you don't need all that other stuff at the input that some people might use to try to improve their AC power. This guy's going to be immune to all that. He's going to regulate the voltage right here. And he's going to work whether you're 120 volts or 240 volts. Doesn't matter. Doesn't care. Plug it in, it works. Okay? So that's why we have 390 volts over here. Then we go into the second stage. And I'll save that for the next video. There's a couple different ways we could do this. There's a number of different ways, but if we're shooting for 300 to 500 watts over here, we want to think about that. So we'll have a plus and minus. Over here I just showed one of the rails. This transformer would actually be a little bit more complex. It'd have another winding, giving us a negative voltage rail. So I didn't show all that. But over here I am showing that we would have a plus minus voltage rail, even though I'm showing a simplified transformer like that. Okay? So hey, if you guys have any input, any suggestions, comments, ideas on which way you think we should go, throw them out there. Let's talk about it. As I say, this is a pulsating DC voltage right here, same as here. So we got low frequency switcher here, low frequency switch here. This guy smooths it out, makes a stiff, you know, voltage with some ripple on it, but it's just a low frequency switcher until you regulate it. This guy starts off a low frequency switcher, same thing, but then it turns into a high frequency switcher, which allows voltage regulation. Once you got regulation going on, now you make yourself not 100% immune, but your immunity to the input goes way up. Okay? Your power supply rejection ratio starts here. Then we're going to have another regulated output, which adds even more power supply rejection ratio. You multiply those guys together, by the time we're done over here, it's immune to this. Essentially immune. You can't put any kind of power conditioner on here. You can't put any kind of power cord on here. You can't put any regenerator over here that's going to work better than this. You just can't. This is going to be the best. These guys are taking over, even though, you know, we love our big old power supplies. These guys are taking over, and for good reason. There will be no hum on the output of one of these power supplies where you can get some hum here. So there's no hum. A lot of reasons to do this. All right? So what do you guys think? Let's go to a slide of pros and cons. All right, guys, I'm back with my new board. Hopefully there's no glare on it. I can't tell from here. All right, so low frequency switcher, linear. Some people call them linears. They're actually low frequency switching power supplies. They have diodes that commutate 120 hertz. So that's a switching power supply, okay? Once you put a linear regulator, which most people don't on their power amplifiers, unless they regulate the input stage, that's fairly common, I think. But otherwise, the output stage is just a, you know, it's big old capacitor with ripple on it. So it's a low frequency switcher. Versus the new age switch mode power supply with power factor correction, 2-stage. So a two-stage converter should do a lot of good. The pros would be performance. The pros over here is just easy. It's just an easy design. It's about the only pro. It really is. As we look through the list, you'll see that that's pretty much all it offers. Over here, under performance, we get power factor correction. We get double regulation because the PFC stage is regulated, which helps isolate the input stage from the PFC stage. Then we go through our next stage and we regulate again. So 2 stages of regulation. We're very much isolated from the input stage. It would not matter what power cord you put on there at all, as long as it can handle the current. So you could add all the stuff at the input stage you want to, and it's just not going to make any difference because we have 2 regulated DC stages. Then we also have no hum. We're, again, isolated from the input stage where the 120 hertz switching noise comes from this way. That's why, you know, generally audio amplifiers have a hum problem, is because of their primitive low frequency switching power supplies. Alright, so low noise. Low noise. But you're saying it's switching power supply, so it's noisy. Well, we can try to filter as much as we can. We can do a good job of it. All the noise, all the stuff that is there is far out of the audio band. So for our hearing, and well beyond our hearing, it's there's no noise. Over here we have 120 hertz, which is very much in our, you know, it's that hum thing again, right? Current limit. I put at the bottom of the list. It could be at the top of the list because it's a safety thing. It protects the circuit from cascaded failures. If you're pushing something too hard, it can save you before anything fails. So you can design it so that it's robust enough that the current limit will protect it before it goes into failure mode. If it goes into failure mode, it will protect so that it doesn't have a domino effect where it just burns down the whole town. So current protection depends on how you use it. Usually the way I design things, I make things very robust. They just don't fail, and the current limit will protect it. If you accidentally short something, you're protected. Over here, with the low frequency switcher on the output power section, without regulation, it's really hard to protect it. You can put another gizmo at the output of your amplifier for speaker protection, but that's just another thing in line with your speaker, and that might protect your speaker, but it doesn't protect your amplifier. So it can protect your amplifier in case somebody short leads together or something like that, but this kind of protection protects everything. If you did have a speaker failure problem, this guy would protect it over here. Over here, it's very tough to do without doing. Now, if you go to full linear regulator, full linear power supply, then now we're talking something different. Now the pros list looks better. Now, I'm not saying better than this, but it's starting to look much better than this. So the non-regulated outputs, current control, non-safety protected, just your pulsating, high ripple. Well, okay, use big enough capacitors, you can take some ripple out, but if you look at the current waveforms, they look pretty hideous. But anyway, yeah, you can make this look better putting a linear regulator on there, much better. And I think we'll do that just as an exercise. Anyway, cons is performance. There's no PFC, so you have to put a big old transformer because you can't use all that power. A lot of it it's reactive power, so it's just being used by the inductance and given back to the input circuit. But you still have to supply it from the input. So if you're pulling 300 amps or 300 watts, you might need 500 VA to do that. Over here, if you're using 300 watts, you need just a little bit above that. You're you know, up in the 90s, I mean, you're looking really close to the power that you're bringing in. Which, by the way, your power cord doesn't need to be as big. And you do get, there's possibility of low frequency noise, right? 60 hertz. And then there's also the thing I brought up in my last rant video. There's a possibility of that ripple being across your output devices, that even though there's good power supply rejection ratio, it doesn't completely isolate you from that ripple. You still see ripple, and the gain of those transistors is affected by that, maybe a little bit, and your feedback should take care of it. But that's just one more thing your feedback has to do. So, and it's different for the, if on a push-pull type amplifier, the positive side versus the negative side, it's different for how it behaves on each one of those. So your feedback is you know, is doing some work to try to keep everything going. So, besides dampening factor and all those other things that your feedback is trying to correct for, it also has to correct for that ripple. It's just one more thing on the load. So it's just feedback circuits going like, geez, guys, just give me more things to worry about. Anyway, over here, none of that worry. You got a nice DC voltage on your output stage. And your input stage, for that matter. So, there you go. What do you guys think? I know I've been purposely pushing some buttons on this video, just kind of, you know, taking stabs at the so-called linear power supply. But I think this is going to be a great series because I'm going to dispel some myths, and I think that's going to make it all worth it. And I'm really happy that John wanted to do this. And you know, he's done a great job in an amplifier design, and so I just want to do a good design on the power supply to match his thing. And by the way, the boards, I like to be able to show the board layout, the routing, all that kind of stuff. I want to do everything. So I'm going to try not to drag this out very long. You know, there's the other side of that where if I do too many videos of just this project, then, you know, maybe some other people watching the channel might not be excited. So I've got some more reviews. I got some stuff to mix in there. I got this Voltcraft meter to review, by the way, and I've got this other Bryman meter. You know, not that one. I reviewed that one. Ah, this one. This EEV blog. Got to review this one. Dave was so nice to send that to me. I need to review that. Got some other reviews to do. I've got some stuff besides this, and some microcap tutorials, which, by the way, I can kind of do two things at once. I can blend the simulation of this circuit in with microcap tutorials, so that's a win-win. So, yeah, give me your ideas. What do you guys think? And if you want to support the channel, that's awesome. Hey, by the way, I just want to say something about, you know, just one of the manufacturers out there. Eve Anna at Manly Labs, man, she's my new hero. Just watching her videos and seeing what they're doing. If you don't believe in switching power supplies for audio, the stuff they do is art. I mean, it's just, I think it's art. I don't have the money to buy one of their, you know, pieces, but I would love to have one just to you know, play with it. But anyway, but it's beautiful stuff. I mean, I watch the videos to see how they manufacture and assemble things, and to listen to her. I mean, she has no ego. Well, I'm sure she does. I mean, come on. Anybody that's that, you know, capable and that's done as much as she has to have a little bit, right? I guess. But she doesn't show it. And she decided to bring in a switching power supply engineer, and she backed him, and man, they haven't turned around. They haven't looked backwards. They've gone straight ahead. They've no more hum. She talks about that. They do microphones. They you know, provide microphones. They do a lot of low noise stuff. So if you don't believe switching power supplies can be low noise, then they wouldn't touch them. But yeah, just check them out. So I just wanted to say that if you're not confident in what we're doing here, check out Manly Labs, and hopefully we can do something close to that. And by the way, I have a couple boards here. I was just going to flash up and show you real quick. There we go. Can't see it from there, huh? Probably can't see it. Sorry. But anyway, just a teaser. There's a board for the output. That's an example. It's around 200 watts, this power supply. It's a eval card, so I can kind of show you what the output of the second stage might look like. And I've actually done a video on this. I'll put the links down below. This is the PFC stage, and I'll redo some measurements. So give me some ideas, things you guys want to see. This is a really cool board. Both these boards are from Texas Instruments. So, yeah, let me know what you think. Okay? And one more thing you might be thinking about is the cost. Now, a transformer like that's expensive. 500 VA, that's going to be really expensive, right? I mean, I think even a smaller, I think we're talking at very least, even if you find a great deal, you're spending over $100 just on the transformer. And then some big caps or something like this, you're spending like another 50 bucks, you know, for the rectifier and the big caps. So I've got another board over here. So yeah, nice way to go for the linear power supply. And then, so I'll build up one of these and put a regulation circuit on the output, see how good we can make it, okay? Another advantage of the switcher is when you buy a transformer, you only can get so many increments in output voltage. So you got to decide, oh, I'm going to get this voltage or this voltage. This one's too high. This one's a little bit too low, but it gets me close to the power I want. With the switcher, dial it in. What do you want? Oh, you want a half volt higher? Okay, there you go. Oh, you want 1/4 volt higher? Okay, there you go. So you just dial it in. So some advantages there. Cost-wise, the transformers, the inductors, and that kind of thing, I think it'll be fun. I think what I want to do, like you can see this PFC. There's this guy here is part of the EMI filter, and this one is the power factor correction guy. So we're going to have an inductor bigger than this, and I'm going to show you how we can make one, okay? So we can hand wind this, all right? So on the second stage, we're going to have a transformer, and we'll look to see what kind of transformer we get. What I'm going to try to do is get a core, and we'll wind it ourselves. So you can just follow the directions, make your own transformer. So I think that'd be super cool. People like that. It'd be fun, right? When we're done with this, we should have like a recipe to follow. You know, do this, 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 and this. And you know what? I think all I'll do is I'll write it up, and I'll have some steps. And for my patrons, I'll just give it to them. Okay. The rest of you guys just watch the video, just copy me. But I'm gonna write. Maybe I'll even publish it on Amazon. But anyway, what I'll do is I'll put a guide. This is how you do it. If you have a different voltage for different amplifier done, it'll be easy to make that change, and I'll talk about how to do, you know, how to change things that you need to change for things like that. But yeah, so I'm excited about this. You can tell I'm just rambling on, but all right. Well, thanks Eve, Anna, and Manly Labs for giving me the confidence to move ahead with switchers and call linears old news. I like them. Got a bunch of these transformers, got a bunch of these, well, a bunch of these guys, got a couple of those, but we're gonna have to use them for something, right? Because we're moving on to switchers, I think. Let me know what you guys think. All right, hey, thanks for watching, and say hi to John. Watch his video down below. Here's videos. I'll put some links down below, and yeah, please support both our channels. Hit the like button. It helps YouTube analytics. It really does help the channel when you hit that like button. Hey guys, I'm back. I had a memory card problem. Put a new memory card in. I can't remember where I was though. No, So anyway, hit the like button, all that kind of stuff. There's a little button down there that if you want to like donate $1 or $2 or something like that, you can hit the little button. I think you can ask a question and it comes up as a starred question for me so I can see it. By the way, I am having a hard time keeping up with all the comments and questions. I love them, and I love to see the interaction with you guys on there. So that's great. I've been trying to hit the subscribers first and then go on to others. And sometimes I find myself just, several hours sitting there just answering comments. So I'm thinking like, I could do a video. You guys would probably rather have a video than me do that. So, yeah, I'm going to have to maybe not spend so much time on that. But anyway, I want to show you this thing too. You guys heard of those ice power supplies or ice amplifiers? Well, this is one of them. I got one. I want to check it out, see what it's all about. I don't think there's anything special. I think it's a real cool name. There's a vendor who makes these chips that are called ice chips. And so, it's a cool name. So we can make an ice power supply too. I don't know if we can call it ice because, well, I mean, it's just named after the chip, right? So why can't we? Anyway, so there's one too. I'm going to show you this power supply. I bought this as an example. This is I believe this is a plus minus 45 volt supply. So there's an example right there. And all right, guys, and there's Patreon links. I think John has Patreon too, so hit him up. Remind him to put that super like button or whatever on his channel. I know he doesn't like to ask for things, but I mean, it takes a lot of money and time to do these videos. Not only taking time from other work we could be doing or family stuff, but just that kind of stuff. It's fun. It's a great hobby, and that's why we do it. So, but at the same time, it's helpful. So, all right, guys. Yeah, buying boards like that or the other boards. Those were eval cards. The first ones I showed you, I didn't pay anything for those, but that one I did, and I've got a bunch of other ones here that, yeah. And you know what? We'll work out some kind of giveaway or something. We'll come up with some kind of thing. I got some multimeters I think I can give away, so we'll come up with something. I have to talk to John about and see how we can get you guys involved and do a giveaway. All right. Thanks for watching, and it's been a heck of a week, and tomorrow's Friday. I'm going to try to post this for you guys tomorrow. It's midnight here, so I have to be up early, but I'm going to try to post this, so hit that like button for me. Thanks, guys. Appreciate you. 2 thumbs up for my patrons. Really appreciate those guys, and I just got a comment on that. It's funny how over like the last year and a half or something, I lose a few and I gain a few. It's kind of just stayed the same for, I thought a year ago, geez, I could be doing this full time, but it seems like even Amazon, well, yeah, the stuff I get from Amazon, even that doesn't really change, and YouTube doesn't really change over the last year. And it's funny because I got so many more subscribers and so many more views I get than I did a year ago. My channel's grown quite a bit, but it's funny how somehow the money hasn't. So, yeah. It kind of scared me when I did taxes, see all the money I spent last year on stuff, and I'm in the deficit for sure. But, all right, guys. Anyway, thanks for watching, and we'll see you next time.